This is a video on flux. The question states, find the flux of F through S with upward unit normal vector. And F of xyz is the vector field 8xi plus 3j plus 2yk. And S is a surface defined by the function z equals 9 minus x squared minus y squared, restricted to the first octant. So let's first recall the formula for flux, and that is that the flux is equal to the surface integral of f dot n ds. And we have a formula that says that that is equal to the double integral over the region R of f dotted with negative g sub x of xy, I, minus g sub y of xy, j, plus k times dA, where g is the defining function for the surface. In this case, g of xy is 9 minus x squared minus y squared. So let's find g sub x and g sub y and plug in. First thing is we have our double integral over R. Our f is 8xi plus 3j plus 2yk. And then negative g sub x, well, g sub x is negative 2x. So negative g sub x is positive 2x. Then times I. And then minus g sub y. Well, g sub y is negative 2y. So minus negative 2y is plus 2y. Then we have j, and then plus k. And that's times dA. So let's take the dot product. 8x times 2x is 16x squared. And 3 times 2y is 6y. And 2y times 1 is 2y. So 16x squared plus 6y plus 2y is 16x squared plus 8y. Then I have dA. So let's look at our region. The region is the part of the xy plane that lies below this surface, 9 minus x squared minus y squared. This is a paraboloid, and if z is equal to 0, that tells us x squared plus y squared is equal to 9, which is a circle of radius 3. Since we have a circle, it's easier to work in polar coordinates. We're also in the first octant, which means that in the xy plane, we're going to restrict to the first quadrant. So that tells us that the limits are theta goes from 0 to pi over 2, that's the first quadrant, and then r goes from 0 to 3, because the circle is of radius 3. And then we have 16, x squared is r squared cosine squared theta, and then plus 8, and y is r sine theta. dA is r dr d theta. So I could integrate this by hand if I wanted to, but instead I actually used a calculator. And I found that the flux of F through S with upward unit normal vector is equal to 81 pi plus 72. And I'm done with the problem.